okay, which would be 7/10 plus 5/10. Okay, this is what's tempting to say. It's tempting, but wrong. Can somebody tell me why? Why is
Because they get the numbers in the middle twice.
Yeah, I counted these guys twice. Okay, so this is wrong. Do not do it. Okay, and it's even easier when you don't have the Venn diagrams drawn out. You see the probability of A union B, and you just want to slap those two numbers together and move on. Okay, so this would mean that the probability of A union B was 12 out of 10, and that is too much. We're over by 4/10, which happens to be the probability of the intersection. Sorry. Okay, so what's wrong with this method? Megan told us correctly. We counted A intersect B, which was the intersection, twice. So how do we correct it? Anybody have any ideas?
You add each number individually, but only once.
So you're saying you would like have the probability of A remove B plus the probability of B remove A?
Okay, like what I mean is like, okay, because I don't know how to explain this,
A
but
remove
basically,
B is this like kind of crescent moon shape, and B remove A is this. So are you saying like
yeah, no, that's not what I'm
plus
saying.
the intersection?
That's not what I'm saying. Well, actually, yeah. So do A remove B, and then B remove A, and then add the intersection, maybe.
So that is possible, but that's a lot more work than we want to do. But it does work. So in order, the simplest thing to do.
Wait. Maybe you could do the same thing as above, but then remove one of the intersection, and then remove subtract one intersection.
Yes, we're gonna subtract P of A intersect B so that it's only counted once. Okay, we want to do, mathematicians are lazy, we want to do the least amount of work possible. So, all right, now, so I'm going to draw out what this looks like. So we're going to have the probability of A union B is going to be equal to P of A plus P of B minus the intersection of A and B. Oops, I'm sorry, you couldn't see that at all. Okay, so this right here is like the equation that we're going to use. That is the addition law for combined events. All right, and then down here, I'm going to draw them in visually so that you can see what we're doing. So we have equals, plus, minus. The union of A and B is going to be all this stuff. P of A is all that stuff. P of B is all this stuff. And the intersection is that guy. Okay, so for this particular example, we get 8/10 for our union, 7/10 for A, 5/10 for B, and we're subtracting off 4/10. What questions do you guys have? Oops. Okay, if there are no questions, I'm going to go ahead and do the example on the next page. Does anybody need me to leave this on this page for a minute or have any questions? Oops. So everybody's written it down and there are no questions? Okay. All right, so we're going to do example 1. It says in a class of 40 students, 34 like bananas, 22 like pineapples. Okay, so we're going to call, let me use some different colors, I think. Well, I'm just going to use pens this time because the highlighter bleeds through and then it makes a mess. Okay, so I'm going to call my bananas P of B. I'm going to underline them in pink. Probability of liking pineapple, I'm going to call P of P. Probability of pineapple. Okay. And 2, dislike both fruits. If a student is randomly selected, find the probability that the student A likes at least one fruit or B likes both fruits. Okay, so I'm going to draw a quick Venn diagram. My first event will be bananas. My second event will be pineapples, and I'm going to color them. My pink and my blue. Hopefully that's easy enough to see, okay? And we know that 2 people dislike both fruits, so there's got to be 2 people outside of them, okay? And there's also a class of 40 students, so 40's got to be on the outside, okay? There's 40 total in this whole thing, okay? All right, so it says how many people like at least one fruit? How do you guys think we're going to represent that? So liking at least one fruit means we could just like bananas, we could just like pineapples, or we could like both. So how do we represent that, like a probability of a set notation?
Wouldn't it be 38 because only 2 don't like fruits?
Well, yes, but how do we write that?
Oh.
Or how do we color it? Like if I drew in a Venn diagram, how would I color that? What would be colored?
The whole thing. All the circles.
Just the circles, yeah. This stuff. And how do I write that like sets? This would be the probability of what happening?
I do not know.
Well, what is this? What do we combine?
Would it
Would
be A, U, B?
Yeah, good. We're looking at the union of those 2 things, okay? So yes, as I think it was Izzy said, there are 2 on the outside of there. We know there are 38 left in that whole section that's colored in. So 38 out of 40, which reduces to 19 out of 20. Okay. Now, likes both fruits, what does that mean? This is going to be the probability of what?
Of where they intersect.
Yeah, where they intersect. So B intersect P. Okay, and I'm going to draw this out. So the intersection is that little guy, right? And so to find the intersection, how can we use the formula on the front to find this intersection? So I'm going to write the formula at the top. So it was the probability of A union B was equal to the probability of A plus the probability of B minus their intersection. Okay, so we know the union, right? We know each of the individual ones, and we're looking for this intersection, right? So we can sub in all the values we know and then solve for this intersection. So in terms of B and P, bananas and pineapples, I would have the probability of BUP is equal to the probability of B plus the probability of P minus the probability of B intersect P. Okay, we know this is 38 out of 40. We know P of B is 34 out of 40. And we know the probability of pineapples is 22 out of 40. And we're looking for the probability of the intersection happening. When we solve this, so we should end up getting 38 out of 40 is equal to 56 out of 40 minus the intersection. Okay, and this should give us that our intersection, sorry that I'm getting all jumbled, should be equal to 18 out of 40, which reduces to 9 out of 20. Okay. Obviously, we don't have time to do example 2 right now, but you guys are welcome to go through and do it. And then there's some you-dos at the bottom. And we will go through, how about, so I want you guys to, you don't have to try example 2 if you don't want to, but at least try these 3 you-dos, or actually there are 5. Try the 5 you-dos, and then we'll start here next class. And I'm not going to check if you do all 5 you-dos. So if you're confident, that's fine. The answers to the you-dos should be on Canvas, so you can check them. What questions do you have? Questions? Does anybody need this screen a little longer? Okay, well, if you guys are good to go and you have no questions, feel free to head out. If you do have questions for me, please stay after so that we can talk about it. And that is all I have for you today. Good luck with all your stuff.